Hello, everyone, and welcome to our latest 802 Tech Talk. Today's topic is IEEE 802.3 Ethernet standards. My name is Jennifer McLean. I'm a Senior Manager for Education Products with IEEE Educational Activities, and I will be helping to moderate today's event. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen are engagement tools that are resizable and movable, so you can move them around to make the most out of your dashboard space. If you have questions for today's panelists, you can submit them through the Q&A widget on your screen, and we'll answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about IEEE 802 networking standards and past and future virtual events. Finally, the on-demand link for today's Tech Talk will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about this event, please use the hashtag IEEeLearn. Our panelists today are Paul Nikolic and George Zimmerman. Paul is chair of the IEEE Committee on Standards, overseeing the advancement of technical standards activities across all IEEE societies and councils, and chair of the IEEE Computer Society's 802 LAN/MAN Standards Committee, overseeing 75 active technical standards and 50 projects under development for wired and wireless networking applications. George Zimmerman is an independent consultant working for CME Consulting. He is a member of the IEEE 802 Executive Committee and is currently the chair of the IEEE P802.3DD and IEEE P802.3DE task forces, and the 802.3 greater than 10 megabits per second single pair Ethernet task force. And he has also chaired the IEEE 802.3 CG 10 megabits per second single pair Ethernet task force. Welcome, everybody, and I'll now turn it over to Paul to get us started.
All right, great. Thanks, Jennifer, and welcome, everyone. Before we get started, just want to make it clear that the viewpoints that you hear today are George's and mine exclusively, and not that of the IEEE's. So let's get started. I will give you a brief, high-level overview of the 802 organization. 802 LAN/MAN Standards Committee develops technical standards for networking applications, and the way we're organized is according to major functional capabilities. The major breakdown, as you can see here, let me try the draw function, this might slow us down, is there's wired and wireless. And today we're going to be focused on the work that's going on in the wired working group, the Ethernet working group, and George is going to be specifically delving into single pair Ethernet. The 802.3 working group basically develops interface specifications for copper and fiber optic cabling. So I want to welcome George. Thank you very much for taking time out to participate in this Tech Talk, George. And George is an expert in single pair Ethernet, and I think it's going to be an interesting discussion today where we delve into some of the drivers behind single pair Ethernet and the technologies associated with it. With that, I do want to remind everyone there's a Q&A interface on 24, and we love to get questions from the audience. So please don't be shy. Put your questions in. George and I are going to talk for about 15, 20 minutes tops, and then we're going to reserve 10, 15 minutes to answer your questions. So please feel free to ask questions. So with that, George, I am going to turn it over to you. Give us a little high-level overview of single-pair Ethernet and what the activities are in 802.3.
So I'll start out by saying, what is single pair Ethernet, because on the surface, it's a pretty straightforward thing. It's just wired Ethernet on a single pair of wires. You know, what is so different about that? Most of the Ethernet that you're used to in offices, it's been around for nearly 40 years now. It runs on 2 or 4 pairs of wire in the same cable, so the user doesn't necessarily have to mess with the fact that there are different wires there. And like I say, on its surface, single pair Ethernet reduces that 2 to 4 pairs to a single pair. That's kind of superficial. Really, what single pair Ethernet is about is a change in applications. And you have to do that, you have to look at conventional Ethernet technologies. Ethernet grew up in the information technology space, designed to interconnect information appliances, computers, printers, communications equipment, storage, things like that. Well, single pair Ethernet really represents the application of the same networking technology to what we sometimes call the Internet of Things, but it's the wires that are found everywhere. Wires that are found in machines, wires that are found in buildings that connect functions. If you look around your room, you know, you will see lights and thermostats and you know, sometimes electronic door locks, occupancy sensors. If you look around a factory, you see flow meters and control servos. If you look at a car, you see everything from door locks and motor units to cameras and displays and self-driving, you know, sensors and computers for self-driving applications. Those are the targets for single pair Ethernet. It's really the movement of Ethernet networking from office computer type technologies into these intelligent functions in what we call operational technologies.
Yeah, that's very interesting, George. And, you know, one thing that I find interesting is that this wired infrastructure still exists and predominates in those areas that you mentioned. And, I mean, it could be served by wireless connectivity, but you can't deliver power through the air. And I think that the reliability is higher over the wired infrastructure. So tell us, George, about, you know, the mission for 802 is to develop technical standards that are market-driven and high quality. How did we get started in this single pair Ethernet? What were the drivers behind it?
So you know, to think about that, you have to ask, how do we do this? How was this stuff done before single pair Ethernet? I mean, certainly we had cars, we had factories, we had thermostats, and you know, strangely enough, you know, single pair Ethernet's pretty new. Go look in your house that's a few years old. You've got wires already there, and so they must have worked some way before there was single pair Ethernet. Most of these applications, whether they're building automation, industrial automation, or control in machines and other vehicles, they ran on proprietary communications technologies, and there was a whole host of them. These kinds of things, particularly in industrial automation, are known as field buses. So you have these various set of technologies, and some examples are a thing called like CAN, C-A-N. It's a controller area network, or LIN, which is a local interconnect network. There are other proprietary technologies like FlexRay and Profinet. But these are all special things that the designers and the implementers and the users need to learn how to manage. So what had evolved was a situation where if I want to run a factory that has a bunch of these technologies in it, or I want to be designing the nervous system of a car which has a bunch of these technologies in it, I have to get implementers who know all this, who know all of these specialized technologies. They're a little harder to find. Additionally, as I want to develop things like security on top of them, I now have to think about developing a bunch of cybersecurity all for that own ecosystem, which, by the way, is already developing for the broader Ethernet ecosystem and interface that serves all the information technology area. So to make the matters worse, Ethernet dominates the back office. All these things end up connecting to the information technology networks. So they need specialized gateways to get to that back office. And so you end up having a drive to be able to connect everything on Ethernet without these gateways, without the extra learning. And thank you, by the way, Paul, for highlighting where that back office is. But I've got this drive to connect it all without the extra complexity and without the extra learning. And so what changed? Why wasn't Ethernet there? Well, originally Ethernet didn't do anything that related to time sensitivity. Ethernet was, you send your email. I don't care that my email arrives, so many milliseconds after it's sent. But if I'm controlling a motor, I care about the round trip time of that information. And the 802.1 group, another one of the groups in the IEEE 802 family, worked and developed a number of protocols to make these networks more time sensitive, to allow the kind of timely response that was needed. And all of a sudden, this area really opened up for wired Ethernet, and we could take these networks and we could make them all the same and leverage the broad base of people who knew about Ethernet and all the development going on there.
George, I think a good example of the need for real-time control is in the automotive sector. Because if you're going to be controlling a vehicle in real time, you're going to have autonomous networking going. When you tap on the brakes, you want to make sure that signal gets sent to your brakes.
Absolutely.
And I think that's a good tangible example of that. Can you give us an example of some of the topologies that are used? These are great examples of applications, but how are they actually architected?
So they differ, and let me take you back to the previous slide here for a moment, Paul.
Sure.
Because they differ depending upon where you are in the world, and where you are in the application space, I should say. If you're talking about the cars, you've got a lot of things that happen in a car that are very much point-to-point applications. So if you look at this car here, and I'll get the little pen, I've got this infotainment system here, right? And it goes from some kind of a controller that's driving the display to a display, maybe up to a camera. Maybe there's a backup camera, but they're all sort of point-to-point links. If I'm talking about the motor control, I might have a string of sensors that run around inside the engine compartment. And I've got, a sensor here, and a sensor there, and another one over here. And in some of these cases, I may really want reliability, so I may even have multiple links coming to them. So with that said, if I go into a building, from one point to another, I tend to have a line. And that's a different kind of a thing. I've got a line from one point to another, and I want to connect up this thing, and this thing, and this thing, and I used a terrible color for that. I apologize. And the same kind of thing happens in a factory where I've got this field bus, and he connects up this guy here and this guy here, and this one here might go down there, and that one there might go down there. And at some point I might have a star, but really these are just spread out, say, along an assembly line. So with that said, and did the slide just change, Paul?
Yep.
Okay, good. So I have control. Then the topology of these networks are different. Your standard office Ethernet network is usually this kind of star topology where you've got a gateway or a switch and you've got a bunch of nodes that come off of it, all point-to-point links. And that kind of works for a lot of these applications. It works for those infotainment applications in cars, which were among the first applications of single-pair Ethernet. But when we went to things that were more control-oriented, we went to these line architectures, where everything's kind of spread out as a line, and then you have two choices. You can sort of connect them up point to point is what we might call a daisy chain, or you can connect them all up to a shared media, which is a bus. So you end up having all of these things in operational technology networks, where in the information technology network, for the most part, you have things that in the local area that have converged around the star-wired topology. Their operational needs why you've got these other kinds of things going on in the operational technology network. And these drive a lot of changes in the wiring needed and in the technologies needed for Ethernet to be successful there.
Yeah, very, very good, George. So the one thing that the group has done is developing a single spec that will address all of these technologies, or are they separate specifications for each of them? Just dive into that just a little bit.
Well, it's an interesting question, Paul, because when I talk to people, what I find is that they often think single-pair Ethernet is one thing, and in a broad sense, Ethernet is one thing. As you know, I know, but maybe some of our audience don't. The IEEE 802.3 spec is more than 1,000 pages.
6,000.
It's actually 6,000 now. I never try to count them all because there are too many. And it's something more than 150, 160 individual clauses. And while that's all one spec, it's really, more than 100 different things. Now, each clause doesn't stand by itself, but some of them, like, say some of the fiber optic high-speed Ethernet for data centers, really never have anything to do with the world of, say, 10-base T1L, the 1 kilometer single-pair Ethernet for factories. Yeah. They all come together at the 802.3 MAC, which is way back in clause 4 of the spec. But we actually have a number of different technologies even within single-pair Ethernet. So there's a bunch of automotive single-pair Ethernets, which go in speeds everywhere from 10 megabits up to the newest one that's being worked on now, 802.3 CY, is 25 gigabits. So it's a full set of Ethernet speeds in a very, very broad sense. Then you have the much more recent work in industrial and in the sort of low-level control. And those were done by 802.3 CG, and actually those are the focus of the new 802.3 DG project that just got approved that I was working on getting started. And those are at 10 megabits, and DG is going to take that to 100 megabits. And they could span point-to-point on a kilometer, or in the case of some of the control stuff, they could do shared media on tens of meters, which is enough to go around an industrial machine or within an engine compartment of a car.
Yeah, I think that is a great overview, George. I think that brings us to the next slide, actually, which illustrates some of what George was saying, is that what we do in 802, and not just in 802.3, but in all of our working groups, is we develop a rich set of tools for the industry to deploy a wide range of hardware and software for specific applications. And even though this doesn't seem to jive with what the point George was making earlier, which was, hey, there's a bunch of proprietary protocols out there that was serving the market, it really is a convergence. We've reduced the number of protocols. We've reduced the number of chips that need to be manufactured to serve all these various markets. And in the process of doing so, we've lowered the cost of deployment, both from a capital and from an operational cost. So maybe you can go into the markets that are being served by all the specs that we're working on, George.
So first, yeah, Paul, as you said, the unifying thing here is the Ethernet NAC and the Ethernet frame. They all use the same one there. But when I go into an environment, what ends up mattering very much is the physical connectivity, what we call the PHY in Ethernet lingo. And sometimes it's, in these cases, it's the power, and then there are other groups that write the cabling. So for building automation, for example, building automation and industrial Ethernet share a lot of commonality. They both, one could say, you have industrial building automation, right? A factory is a building. So the distances are long. And for that, we developed this 10BASE-T1L technology. That's the 10 megabit, 1 kilometer type of technology. And recognizing that there are also sort of little machine interconnects in there, things that go on either inside a machine or within little groups of machines that might be low bandwidth and use a shared media bus. We have what we call 10BASE-T1S, which is actually a return of Ethernet to its roots as a shared media technology. Everybody uses part of the same bandwidth. And there's a new project extending that called 802.3DA as well. So you can see that in both. You can see DA up in building automation, which is making this more plug and play, and 10BASE-T1S down in industrial Ethernet, which is used in the world. And extending these families is something that happens as the market starts to take off. So 10BASE-T1S and 10BASE-T1L are coming to market today. So you have new projects in 802.3 that are defining the next step in those. 802.3DA for the 10BASE-T1S and 100BASE-T1L or 802.3BG for the long range point-to-point, taking it to a higher speed. In addition, each one of these technologies has needs for power. And this is where sometimes 802.3 says, this is really, really application specific, and maybe we should leave an adaptation to the industry. So while we have a single pair power over Ethernet, Clause 104, SPOE, used to be called PODL or Poodle, but that really ended up being much more for engineered systems like cars. It's a whole other topic we could get into. When we get to industrial Ethernet, they have things like explosive safety environments. And we said, let's leave that to the guys, to the industry experts who really do that work specifically. And so there are other groups like the Advanced Physical Layer Group, or APL, who have defined engineered power that fits in those kinds of environments. Now,
okay, great, George.
Take a moment over. Okay, I'll just finish up then.
Go ahead.
So contrasting all this are the things that happen inside machines, and those happened first. And automotive Ethernet, as I mentioned, is everything from 10 megabits to now working on 25 gigabits. It's a rich set of standards, but it's all short reach. So those are all kind of special purpose as well. And a lot of that technology is being used inside pieces of equipment, these intra-system links.
Okay, very good, George. George, this is a wide range of capabilities that are being developed inside 802.3 and being deployed by the industry. Now, can you give us a sense of, the types of people that are actively involved in developing these standards, and how can some of our audience members participate in standards development?
So first of all, as far as participating, anybody can join and come to an 802.3 meeting or an 802 meeting in general. And this is actually a great time to do it because right now the meetings are still virtual. And most of these groups have ad hocs or interims every other week. So if you go to any of the 802 web pages, which Paul has a slide that talks about that, why don't we go to that, Paul? I'll do it. There we go.
Yeah. Okay. Thanks.
So if you go to these pages, you can find under 802.3, there's actually a calendar link, and it's got where all of these meetings are. There's also, each project has its own web page that'll tell you more about it. So anybody can join. And in fact, when you think about all of the things we've talked about, we need people from all walks of life. We've got guys who are coding theorists. We've got people who are affiliated with semiconductor, communication semiconductor manufacturers, people who are affiliated with networking equipment vendors, and everybody kind of expects those sort of people to show up. People who are specialists in designing, for example, automotive cables. They show up in the automotive Ethernet groups, and they're actually a different bunch of guys than the ones who show up in the information technology cabling area or in the industrial Ethernet cabling area. But we also have people who are applications oriented. So there are folks who show up who are interested in and know about the constraints involved in motor control, or know about one of my good friends is somebody for GM who's working on all the electrifying cars, all the control involved there. Another guy I know is in another automotive manufacturer and is involved in self-driving applications. Anyone who's interested in moving this forward for a particular application brings a new perspective to the group, and it helps us figure out whether it works within the current technology base, or we actually need to expand further and meet the needs of that market segment.
Yeah, excellent. Thanks, George. Yeah, I mean, just to tag on to what George is saying, we welcome people to come in and participate. And, I know sometimes people are intimidated, like, oh, I'm not a worldwide expert, and I'm not sure that I can engage in standards activities. Absolutely not. In 802, we want you to come in. Yeah, there's a little bit of a learning curve associated with it, but if you have expertise and you feel that you can contribute, you're more than welcome to come in and participate. George, we've got a couple of questions I'd like to address before we wrap up. Here's one. Can single-pair Ethernet work in artificial intelligence and cyber physical systems technologies?
So certainly, anywhere that you can have anywhere that you can have a networking technology with 4-pair Ethernet, you can pretty much have single-pair Ethernet. Single-pair Ethernet is much more of the physical infrastructure than what you're talking about are applications-oriented technologies. So if I think about like security protocols, right? So MACsec will run on top of single-pair Ethernet. If I'm thinking about artificial intelligence, often there are latency and data rate constraints that might constrain which single-pair Ethernets might apply, since single-pair Ethernet is newer, right? The automotive area, those types of single-pair Ethernet, I believe, are certainly rich enough to support artificial intelligence. Maybe not so much with the industrial stuff that long reaches, because 10 meg and 100 meg are often a little slow for those applications. So
Right.
in principle, though, and if you have such an application, you can do it.
Yeah. Another question is, are there practical applications using single-pair Ethernet in manufacturing lines or specific vehicles?
So we have to be a little careful. In IEEE, we try very hard, or actually IEEE SA, we try very hard not to give any kind of product pitches. But I do know of many examples of single-pair Ethernet in specific vehicles. And in fact, it was the first single-pair Ethernet in vehicles was deployed almost simultaneously with the first automotive single-pair Ethernet standard. If you're familiar with those, if you get in the car, if you're familiar with those infotainment systems that provide the 360-degree view of the car, some of the early ones of those, and without doing the product pitch, I'd say that was kind of known to be in the BMW X5, was deployed with the 100-base T1 single-pair Ethernet technology, and was an early application of it.
Yeah.
Since then, it's spread into multiple places, and multiple vehicle manufacturers are using single-pair Ethernet.
Okay, very good, George. Last question, and then we're going to wrap up. What are the most difficult technical challenges that we have in our single-pair Ethernet activities to address? And what are the real hard problems that you're attacking, George?
Well, so honestly, what's hard depends upon who you're asking. You get a bunch of different experts, and what's hard to one person is maybe easy to another. And that actually goes to your point, Paul, about why we not only welcome, but we really need a lot of viewpoints. Because somebody comes in who's not normally in the Ethernet ecosystem and say, oh, I know how to solve that. And it's easy to them. To me, though, when I look at these single-pair Ethernet environments, I see a situation where we have a different noise environment than you have in offices, and that you usually have in high performance communications links. A lot of impulse noise, things, motors going on and off, and in a vehicle there are all kinds of things that are spinning and sparking, and they make noise that create errors in the link. So we need to be resistant to that. At the same time, we need to be very time sensitive, because a lot of these things require closed control loops. Those two requirements actually kind of beat against each other. So we need to be clever as to how we solve those. Other people would say making nice high bandwidth cables in a high temperature environment like you often find in an engine compartment is its own big technical challenge. So there are a number of very specific challenges to these areas, and the more experts we have in, the better we can address them, and also the better off we are in terms of not missing something. Right.
Yeah. We'll close now, George, but this triggers in my head when we were having a next generation technologies discussion in 802, and one of the wireless guys mentioned, hey, these undeterministic channels are a real problem, and we're working on that. And a light bulb lit up in your head saying, hey, we got the same problem over here in the wired domain. And
that's right.
And let's tap into that global expertise that's out there that the people that are listening in represent. So with that, we'll wrap up. Thank you very much, George. This has been great, and I'll hand it over to you, Jennifer.
Yep, thanks very much to everybody who participated today, and thank you, George and Paul, again. As noted earlier, the on-demand link for the event today will be emailed to everybody in about 2 hours from now. We invite you to register for our next IEEE 802 Tech Talk, which will be on April 27th on the topic of 802.15, and you'll be able to find more information soon about that session on innovationatwork.ieee.org. And before you leave today, if you could complete our feedback survey via the survey tool at the bottom of your screen, we'd really appreciate it. And once again, we thank you all for your time. Have a great day.
Thanks, everyone. Bye. Thanks, George.
Thanks.